NASA's Perseverance rover is well into its second science campaign, collecting rock core samples from features within an area long considered by scientists to be a top prospect for finding signs of ancient microbial life on Mars. The rover has collected 4 samples from an ancient river delta in the red planet's Jezero crater since July 7th, bringing the total count of scientifically compelling rock samples to 12.
The mission is proceeding extremely well. We are making very good progress at understanding the geologic history, finding some surprises in the history of the crater, and we are also making good progress in collecting this suite of samples for the Mars sample return effort. And what you're going to hear is that the suite of samples that we have collected so far is sufficiently good that we are now considering them putting down a subset of them on the surface of Mars as a target for the future missions to pick up and bring back. And the reality is the burden of proof for establishing life on another planet is very, very high. And it seems unlikely to most of us that the evidence will be so compelling that we will be able to do that. And I just want to make the point, the rover can only make the kinds of observations that we thought of building into the rover years ago. That's very different than terrestrial laboratories where you can say, well, if we just make this kind of observation, some new thing that we hadn't thought of, that'll answer the question. Rover can't do that because the rover only has what it has. So this is one of the reasons why bringing samples back to Earth is so important. So in answer to that question, I think it's not very likely that we will make a definitive detection of life. About the best we are likely to be able to do is this potential detection.
28 miles wide, Jezero crater hosts a delta, an ancient fan-shaped feature that formed about 3.5 billion years ago at the convergence of a Martian river and a lake. Perseverance is currently investigating the delta sedimentary rocks formed when particles of various sizes settled in the once watery environment. During its first science campaign, the rover explored the crater's floor, finding igneous rocks, which forms deep underground from magma or during volcanic activity at the surface.
It's clear that we are uncovering a bigger story that's happening in Jezero crater. So we found signals that we think are possibly from organic matter on every target that we've observed with Sherlock to date. And this isn't really unexpected. It aligns with what we've learned from studies on Earth and Martian meteorites and from Mars research from our sibling rover Curiosity. However, it does say that organics seem to persist in the very harsh Martian surface environment, which is very exciting for us.
Sherlock's analysis indicates the sample features a class of organic molecules that are spatially correlated with those of sulfate minerals. Sulfate minerals found in layers of sedimentary rock can yield significant information about the aqueous environment in which they are formed.